Today we talk about an example from the last lecture. It's about lateral shift of light rays when passing through a glass plate. Now, this example is about double glazed window. What is a double glazed window? It consists of two pieces of glass, and in between there is a layer of air. So let's draw this double glazed window. This is one piece of glass, and I have a second piece of glass. This is glass, and this is also glass, and in between I have air. The light ray shines to the first piece of glass, and the light ray is refracted inside the glass. When it leaves the first glass, this is the light ray leaves the first piece of glass, and it enters the second piece of glass. And then it leaves the second piece of glass. Lateral shift. Look, let me extend the incident light. This light ray comes out from the first piece of glass, and it is shifted laterally. This is the amount of shift. Now, when it enters the second piece of glass, and it leaves the second piece of glass, it has another shift. This is the second shift, and this is the total shift. The total shift is the shift, lateral shift, between the original incident light and the final exit light. So this shift is the total lateral shift. From the diagram, it is very clear the total lateral shift is the sum of the first lateral shift and the second lateral shift. It is also very clear that how thick the air layer is has nothing to do with the total shift. So this thickness is not related to the final shift. This is very obvious from the diagram. Let's do this example. The thickness of the glass pieces is 32 millimeter. So this is the two pieces of glass are of the same thickness, 32 millimeter. How thick is the layer of air? It is 25.6 millimeters. The thickness of the air layer is 25.6 millimeters. As we explained a few minutes ago, this thickness has nothing to do with the total lateral shift. So the total lateral shift is 2 times the individual shift, 2 times this lateral shift. Let's do the calculation. From part 1, from the lateral shift part 1, we have the formula. The shift this is the lateral shift. Lateral shift equals thickness of glass times a fraction times a fraction. The top is sine angle of incidence minus angle of refraction. The bottom, the denominator, is cosine angle of refraction. This is derived, this is proved in part 1 of lateral shift. So we need to use this formula. To use this formula, I need angle of incidence. This angle is given in the question 50 degrees. However, 50 degrees is not called the angle of incidence. Angle of incidence is the angle between the light ray and the normal line. This is the normal line. So the angle of incidence is 90 degrees minus 50 degrees, which is 40 degrees. So theta I is 40. Thickness of glass is 32. So the shift is 32 times sine angle of incidence is 40 degrees minus angle of refraction. But what is angle of refraction? Let me see this. Okay. I'm sorry, wait a minute. I copied the question wrong. This angle is 40. Okay. I copied the question wrong. This given angle is 40. Therefore, the angle of incidence is 90 minus 40, which is 50. Okay, so its angle of incidence is 50. Actually, whether the angle of incidence is 50 or 40, you just do the calculation. It doesn't matter very much. But why do I switch to the 40 and 50 there? It's because this question is from York University physics assignment. It's from York University. York University physics assignment. So I stick to the numbers given in that question. Okay. Now I want to find angle of refraction. How do I find that? Snell's law. Snell's law, n1 sine theta 1 equals n2 sine theta 2. Let's say 1 is air. So let's say this is air. Therefore, n1 is 1. The index of refraction of air is 1. The sine theta 1 is the angle of incidence, sine 50 degree. And then n2. n2 is the index of refraction of glass. Now, in this question given by York University, the n is 1.44. The index of refraction is 1.44. So I have 1.44 sine this theta 2 is the index of refraction. So from this, I can find our theta r, index of refraction, which is, use a calculator. Okay, I'm not going to show you the calculator and the calculation. The result is r theta. Theta refraction is here. I write down all the digits from my calculator. So you can check that, okay, by yourself. So this is theta refraction. So you put this number there now. The bottom is cosine angle of refraction. So it is so just insert your calculator answer into the formula, and then use calculator again to find this lateral shift. What is the answer there? And okay, let me erase this line, Snell's law. What is this answer? This answer, show you this. This answer is, use a calculator. This is the answer. The shift is this much. As we explained, the total shift after passing through two pieces of glasses, the total shift is the sum of each individual shift. But since the glass plate has the same, since the two glass plates have the same thickness, so these two shifts are the same, so the final shift is just double that. So you have this, right? Let me erase this part. The final shift is equal to 2 times this. And what is this equal to? Use your calculator. And then you can round it. And the unit is millimeter, because everywhere the unit is millimeter, so you have that. And this answer agrees exactly with the answer given by the university assignment. I want to make a remark that in doing numerical calculation, it is better not to round this answer, not to round it, not to round it, not to round it. Keep all the digits, and you round your final answer. This will guarantee that your result agrees with the textbook's result or agrees with the result given by your professor. If you round this and then do the calculation, your final answer may be off from the answer in the textbook. Okay, that finishes the example of the lateral shift of light rays passing through a piece of glass. Thank you for watching. This is YC Tutoring. Goodbye.